Hello, and welcome to this series on the multiphysics analysis of a car headlamp. In the previous videos, we saw how SimCenter 3D provides an advanced geometry preparation, meshing, and solution setup tools that allow you to manage the multiphysics digital twin in a robust and efficient way. More specifically, in the last video, we set up some quick and easy test solutions for the various physics we want to simulate in this headlamp. For this video, however, we will add radiation enclosures to this model, as well as combining all our previous solutions into one final structural thermal flow multiphysics analysis. For this video, however, we will add radiation enclosures to this model, as well as combining all our previous solutions into one final structural thermal flow multiphysics analysis. In solving thermal radiation models, the most computationally expensive portion is the view factor calculation. One method to reduce this computational time is to explicitly define the radiation enclosures.
In this example, we know how much energy the tungsten filament is radiating to the surrounding glass bulb. Thus, we will be defining separate radiation enclosures for each one, selecting the filament and the glass bulb surrounding it. We also know that we are working with specular and transparent optical properties, which means that we are going to be using the deterministic calculation method for view factors. Now we will repeat the same steps for all other bulbs in this assembly, which there are 4 of. Another check that we always want to do for radiation is to look at the element normals. This ensures that we have the correct optical properties for both the top and bottom surfaces.
Once our radiation enclosures are defined, it's as simple as creating a new solution and including all the previous boundary conditions we created. We included some new flow surfaces for the structural to flow interaction. We're reusing our surface-to-surface contacts that we created for the structural analysis and for the thermal analysis. We're adding some convection to exterior and convection to interior boundary conditions for the thermal solve. We're also reusing our 2 fixed conditions from the structural analysis, as well as adding a gravity load and adding 4 thermal loads for each of the tungsten filament in this headlamp. And that's all. Our structural thermal flow multiphysics model is ready to be solved.
In this video, we saw how we can quickly set up radiation enclosures for this complex headlamp assembly. We also, in a very streamlined way, set up a single solution including simulation objects, loads, and constraints for the thermal flow and structural solvers. Our next step is going to be to verify that the lighting system we've created performs as intended. SimCenter 3D offers a number of different methods of visualizing results. This is going to be the topic of the next video. Thanks for watching, and see you in the next one.